Hello there. In this video I'm going to be covering some of the basics of float control such as loops, if statements, and functions. This video works off the basis that you have watched the Universal Basics video in which the ideas of these concepts have been explained already. There should currently be a card on the top right of your screen to that video. It also assumes that you have a basic project structure such as that of my dedicated video on that, where you would have a project structure similar to this. You may or may not have contents in the out directory. So let's jump straight in. I am going to use my editor of choice, which is NeoVim, to open these relevant files, and from there on we can continue. In the project setup video, over here we have already created a function. As we can see, it starts off with the return type, which in this case is a void, then the name of the function, a pair of brackets without contents, and then a pair of curly braces within which we have our printf statement. The first thing to mention here is what is called the return type. A void return type means that there is none. It means that this is expected to be doing something, however not to be giving anything back, which means that we do not need to return anything. Now, the reason why functions have a return type is to take an example from my video on the Universal Basics. We should have a function which can calculate a result out of applying a formula to a whole bunch of input values. So then this output value, we'd have to say it should be an int, in which case we would have to specify the return type to also be an int. Another reason why one might use a return type even on functions which are fundamentally that of a void is for error management. One could have a longer function where they can check whether something works out the precise way it's supposed to, and if it does, they can return a 0, or if at any point they detect an error, they can return a 1, so that wherever this function is called, they can see whether it was a 0 or a 1 and act accordingly. But let's get back to the example of the formula. Assuming this is going to have a return type of integer, and then we want the function to receive, say, an integer for health and an integer for damage, for a very simple one. Then we should simply here return health minus damage. Now, if in the main.c function we were to say int remain health equals to, and then we can set this to be equal to the function, and of course we also need to pass through our two values for health and damage. The reason we set a new variable equal to a function is because this means that the function is going to be called, and whatever it returns is going to be what we set the variable equal to. So in this case we set int remain health equal to whatever, calling print hello with 120 returns, meaning that if we subtract the 20 from 100, this means that it returns 80, meaning that our variable here, which we have created, will carry the value of 80. Of course, one could have more complex formulas, such as having a two-dimensional distance function. The way this works is we could have a function which has a return type of a float, which calculates the distance, and then it wants a variable for x1, y1, x2, and y2. And then this simply returns the square root of x1 by y1 plus x2 by y2. Of course, we also will need to include math.h, which we will of course also in the mate file need to give the flash of lm, specify that we wish to have math included in our project. Now we can quit out of here, we can compile, and oh yeah, this is actually an error I have made. This error tells us that we have given too many arguments to the function of print hello. It had the expected 0, but it has been given 2. Now this may seem peculiar as we have defined the function to want two variables. However, here it tells us that in src/utils.h we have defined it without wanting any arguments and not even being an integer of a return type. We can simply track this by quickly editing the utils.h file and replacing the void with an integer, giving it an integer of health, and finally an integer of damage. Then we can quit, compile. Oh right, the problem is that in the mate file we are not actually using the flags variable yet. Now over here in the mate file we will, in our program rule, just need to add $, brackets, flags, so that this references our -lm. Now we can finally quit, compile, and run. And of course, we currently do not yet have any visual feedback. However, this looks correct. So let's resume back to the editor, maybe to add some feedback. Oh yeah, currently we are not even referencing the dist function to be actually used anywhere. The reason why I'm actually using a float for the return type here is that even if we put in integers as the coordinates between which we want to get the distance, it will likely be a decimal value, so we need to use something other than integer. You could just as well use double here instead of a float. A quick way to test that the dist function is working is we could here in this print statement put a %f for float, and after the quotation marks add in a comma, dist, and finally in the brackets put in 4 distance values. So let's say 0, 0, 1, 1. This should just be a very simple diagonal line. The last thing we actually need to do is, as you will have likely already recognized, this is not the correct distance function. We will need to put brackets around these, around the x1 by y2, and the same thing for the second, and instead have this be x2 minus x1 by, and then in brackets again, x2 minus x1 plus y2 minus y1 by y2 minus y1. Now finally, when we quit out, we can compile and make, and we see the correct value for the distance. The next relevant topic is loops. As the Universal Basics video will have covered, loops can be used to repeat a certain piece of code for a desired amount of times. A very simple example we can use is returning to the main.c file. We can use a simple for I loop to repeat something, say 10 times. The way we do this is we say for, and then we need to in brackets that we declare a variable of integer I equals 0. So this is the starting point. Then our condition for the loop to continue going is that I is smaller than 10. We separate these with semicolons, so we add a second one of those. And finally we say I plus plus. After the brackets, we can then add curly braces. What this does is that to declare our loop, we have a variable of I. Once the code within these curly braces is finished executing once, it will check whether I is smaller than 10, and when it is, it will add 1 to I. This is what I plus plus means. You can also have mechanisms such as I plus equals to 2, which means that it will skip every second one. However, I will just use I plus plus, and then it will execute the code again, check whether it's smaller than 10, until it is, and then it will continue with whatever we have after the for loop. The reason why it is quite useful to have this I value is because, say, we could have a printf in which we say current iterator is %i /n. After the quotation marks, we can then put the I and finish off with a semicolon. And if we were to compile this and run, then it will print out all of our numbers from 0 through 9. This means that the one line, current iterator is I, has been printed 10 times. Now for people used to certain other programming languages which are slightly more human-faced, you will notice that it ends on the iterator of 9 and starts on a 0, instead of starting on a 1 and ending on a 10. The reason is quite simple and quite clear when looking at how we've defined the for loop. The variable starts with a 0, we execute the code, and then add something to I. So this already explains that we start at a 0. However, the condition is that our number is smaller than 10 for it to end the loop, meaning that it will never execute the contents of the braces when I is 10, but only one last time before it is 10. This can of course easily be combated by just in every reference of I adding 1. However, usually you have no reason to do this, as tables also operate in a manner where the starting point is a 0. Now, in my Universal Basics video, I had covered that there are 2 more types of loops, the while loop and the for object loop. The while loop can quite easily be done here. I will just have an integer for anything, which I set to 0. Then I check while my integer is not equal to 10, and then we can have our braces again. So the condition under which the while loop will continue executing is whatever is in this bracket. So the moment this condition is not fulfilled anymore, it will stop executing. We can quite easily even emulate a for I loop in here by saying printf current iterator colon space %i after the quotation marks comma ASDF, and then just say ASDF++. So now if we compile and run, we can see that it once again counts up 0 through 9. While loops can have other uses than just being a other type of for loop, however. They can be used, for instance, in combination with user input to repeat an action until, say, a user does something very specific, or until another external variable reaches a specific conclusion. The use of this is up to you to figure out. The last type of loop which I had covered was the for object loop. As I had also mentioned in that video, certain languages such as C do not have a for object loop, as it can very easily be emulated within the already existing parts of the language. The way I am going to demonstrate this is by having a table of characters with, say, 5 elements, and then I'm going to set this to curly braces in which I have A, D, R, F, T. Just various random letters. Now, a simple for object loop I'm going to write is to iterate through this list of characters and just print them all. So the way this can be emulated is by having a regular for I loop which iterates through the amount of characters. So I'm going to go int I equals 0. I is smaller, and at this point I could either say 5, because here I've defined my list to contain 5 elements, but assuming that I do not know precisely how many elements I have in the list, I can find out how many there are by calculating it based on the size. The size of function passing in the list will give the size of the array in bytes, and as technically a character is a single byte in size, this is already sufficient to know how many characters there are. However, assuming you're not using characters, which have a very easy to figure out amount of bytes, you would divide the size of the list through the size of the first element in the list by using size of list and then square brackets 0, which in this case will give the size of the first character, which is 1, meaning we divide 5 through 1, which just gives 5 again. The last thing is again to just I++, and then in here we can look at I as the how manyth element in the table we are currently looking at. So we can create a variable for our element, which is just list brackets I. And just to quickly validate this, we can printf %c for character, comma, element. Now if we compile and run, it prints out each of these characters one by one. This should also work for more complex lists of objects than just a list of characters. The last thing to cover is the if statement. I'm going to zoom back to the editor. An if statement is very simple. However, it is one of the most important tools of a programmer. Assuming we had a simple for loop like we had earlier, we should have a if statement to check whether our iterator is a certain number to do something very specific in that case, which would create a structure such as this. Over here, we have our if keyword, then we have brackets in which we have our condition. Under these conditions, the code in these curly braces will be executed, and then behind this curly brace, we can have either an else if, or just nothing, like here at the end. Currently, we have one condition for whether I is equal to 3, or all other cases. We could also then beyond here just have something that executes no matter whether I is 3 or not. To keep in mind is that everything within the else block will only be executed now if I is not equal to 3. We could also have a else if I is equal to 5 and just another else here. Now we have 3 conditions. I is 3, I is 5, or I is 1, 2, and the rest of them. The conditions can also be a bit more interesting, such as we could say I %2 is equal to 0. What this means is whether I is a even number. And of course, this should also check for external factors, such as something controlled by user input. The use for this is once again something that will be entirely up to you to find, as it has a lot of uses, but it's hard to find a very good example. And with that, I would like to thank you for watching. If this video was helpful to you, then it would be greatly appreciated if you could like the video and leave a comment. Currently on the left side of the screen is a playlist to all of my C tutorials, whilst on the right is the video on the general basics of programming, which I've been referencing a couple of times. Thank you.